Okay, so question number 1. An invasive species of plant appears in a fruit grove at a time t equals 0 and begins to spread. The function c defined by c of t. So they gave us c of t is equal to 7.6 arctan means tan inverse or shift tan 0.2 t. Models the number of acres in the fruit grove affected by the species t weeks after the species appears. It can be shown that c prime of t is equal to 38 over 25 plus t squared. Okay, so you're given the function c of t and c prime of t. In part A, they said, find the average number of acres affected by the invasive species from t equals 0 to t equals 4. Show the setup for your calculations. Remember to have your calculator on radians, so make sure that this calculator is in radians and not degrees. Okay, and so let's start with the first part. Average number of acres. The number of acres is represented by the function c of t. So when you say the average number of acres, it means they want the average value of a function. What is the rule for the average value of a function? So the average value of a function f of x is equal to 1 over b minus a integral from a to b of f of x dx. That's the rule that we're going to use in this question. So the average value of a function is 1 over b minus a integral from a to b f of x dx. So in part A, we are going to do, in order for us to get the average number of acres, so we're going to write average number of acres is equal to 1 over, what is A, what is B, from t equals 0 to t equals 4, that's your A and that's your B. So 4 minus 0 integral from 0 to 4 of c of t dt. And how are we going to, so this is a graphing calculator question, calculators are allowed. So all you have to do is on your calculator 1 over 4 integral from 0 to 4 c of t is 7.6 tan inverse 0.2 t dt. So let's type that in on our calculator. That's part A. So 1 over 4 integral from 0 to 4 of 7.6 shift tan 0.2 alpha x. Okay, so instead of t, you're going to write x because it's in terms of dx, so integral in terms of dx on the calculator. So 1 over 4 integral from 0 to 4 of our function equals, you get 2 points, so 3 decimal places. Your final answer in the free response questions should always be to 3 decimal places, so 2.778 is your final answer. Okay, and of course you have to write it as a full sentence. What did they ask? Again, find the average number of acres. So let's write it down. We say therefore the average number of acres affected by the invasive species from t equals 0 to t equals 4 weeks is approximately 2.778 as a full sentence. Okay, and that's our final answer for part A. So we can look at the scoring guidelines. Okay, so you get this answer 2.778244, but of course 2 to 4, but of course you have to round your answer to 3 decimal places. So from time t equals 0 to 4 weeks, the average number of acres affected by the invasive species was 2.778 acres. So go back. Okay. And that's our final answer for part A. Okay, in part B, what do they want? They said, find the time t when the instantaneous rate of change of C equals the average rate of change. So we all know that instantaneous rate of change is just the derivative, C prime of t. So instantaneous rate of change of C of t, they want us to equate it to the average rate of change of C of t on the interval 0, 4. Okay, so what is the rule? We know instantaneous rate of change. We know that's equal to C prime of t is going to be equal to, what is the average rate of change? In general, what is the rule? So in general, the average rate of change of any function f of x on the interval AB is f of b minus f of a over b minus a. Notice that in part A, it's the average number of acres. It's called the average value of a function, whereas here it's called the average rate of change. Okay, and so that's the rule for average rate of change in terms of our function here, or our question, C of 4 minus C of 0 over 4 minus 0, and we can do this on the calculator. So keep this on the side. That's our rule. And C of 4 minus C of 0, so we can do this on the calculator. Our function C of t is 7.6 shift tan 0.2 times 4 minus 7.6 shift tan 0.2 times 0 over 4 minus 0, exactly as I wrote over here, is equal to, don't round this answer yet, okay? So this is not our final answer. So we need to equate C prime of t equals 1.28200779022. So what am I going to do? Since I'm allowed to use a graphing calculator, I can use the graphing function. C prime of t, I will just get the graph, or I will draw the graph of y equals 38 over 25 plus t squared, okay? And for this value here, we can call it y equals this value. So here we have y1, here we have y2, and in order to, so when you equate them, it means you're getting the intersection of those two curves, y1 equals y2. If I get the intersection, I will get the value of t. So let's graph those two functions. Now I'm going to use Desmos. I'm going to close this calculator. Okay, and we're going to use Desmos. Okay, so here we are, good notes. And we're going to use Desmos now instead of the other calculator, just because it's more clear. So y equals 38 over 25 plus t squared. Instead of t squared, I'm just going to write x squared. Okay, so they drew the graph for me, and I'm going to write the other equation, y equals 1.28200, 00779022, again 9022. Okay, the exact value. And so they drew the graph for me over here, and we can see, of course, we don't want the negative point of intersection, because the negative point of intersection, so it gives me t equals negative 2.153, and time can never be negative. Time is always positive. So since time is greater than 0, Okay, then the intersection, you get your answer. Therefore, you get your answer t equals 2.154 to 3 decimal places. So you get t equals 2.154. Okay, so find the time t. Yeah, we found the time t at which the instantaneous rate of change equals the average rate of change. And we showed all our work. So let's have a look at what they want us to write in the scoring guidelines. So in part B, you must use the average rate of change. That's what we did. So we got that. And then we equate c prime of t to this value, and we get t equals 2.154, exactly what we got. So therefore you say the instantaneous rate of change equals the average rate of change at time t equals 2.154. Okay, and that's our answer for part B. Okay, in part C, what do we have? This was a very easy one. They said, assume that the invasive species continues to spread across according to the given model for all time t is greater than 0. Write a limit expression that describes the end behavior of the rate of change. We know that c prime of t is the rate of change. And what does end behavior mean, or a limit expression for the end behavior? It's simply the limit as t goes to infinity. Okay, of the rate of change, it means of the function 38 over 25 plus t squared. Now we all know the limit as t goes to infinity, when infinity is in the denominator, is going to be equal to 0. And that's the answer for part C, as simple as that. So let's see what they want us to write in the scoring guidelines. That's it. So all you have to do is write the limit expression and the value equals 0. That's the answer for part C. Okay, so if you want as an extra step to write the limit as t approaches infinity of c prime of t, okay, as a first step, equals the limit as t approaches infinity of, you substitute c prime of t, here it is equal to 0. That's it for part C. Okay, and we don't need this anymore, the Desmos calculator, so I'm going to close it. Okay, and in part D, what do we have? Let's get the other calculator. Okay, here it is. Clear everything. In part D, they said at time t equals 4 weeks after the invasive species appears in the fruit grove, measures are taken to counter the spread of the species. The function a defined by a of t equals, so I like to write it down, so I'm just going to write it. A of t equals c of t minus the integral from 4 to t of 0.1 ln x dx, right? So what does this remind you of, this integral here from 4 to t of 0.1 ln x dx? This is the first fundamental theorem of calculus. So before continuing to read the question, let's write the rule for the first fundamental theorem of calculus, or principle of calculus. If we have capital F of x equals the integral from a to x of f of t dt, then the derivative f prime of x is just equal to f of x. Okay, so we replace the t with x. Okay, so that's the first fundamental theorem of calculus. And so over here, they gave us the function a of t, and they said it models the number of acres affected by the species over the time from 4 to 36. So the time t is now between 4 and 36. What's the question? At what time t is between 4 and 36, does a attain maximum value? So does a attain its maximum value? So in order to get the maximum value, we have to do a prime of t equals 0, right? So we have to derive a prime so a of t. So a prime of t is equal to c prime of t minus by the first fundamental theorem of calculus, this is going to be equal to 0.1 ln t. Okay, so 0.1 ln t. So if we derive this, we're going to get, instead of x, you just replace it with t. So 0.1 ln t. That's a prime of t. And we're going to equate that to 0. Okay, so let's graph this function over here, c prime of t minus 0.1 ln t. So c prime of t, we know that it's 38 over 25 plus t squared, okay, minus 0.1 ln t equals 0. We're going to graph this function, and equals 0 means we're going to check where it intersects, at what point does it intersect the x-axis, right? The roots with the x-axis. So let's open the Desmos calculator. So we're going to close this calculator and open the Desmos calculator. Okay, we have the function y equals 38 over 25 plus x squared minus 0.1 ln is ln x. Okay, and that's our function. Now to get the intersection with the x-axis, here it is 11.4417. So therefore t equals 11.4417, but that's not our final answer. That's why I didn't round it to 3 decimal places. So how do I get the maximum value? I must check the value of the function at time t equals 4 and at 36 and at t equals 11.4417 before I conclude. So we're going to draw a table, and we're going to say t and a of t, and the time equals 4, time equals 11.4417, and time 36. So at those values of the time, what is the value of my function a of t? So we're going to substitute 4 in a of t. Okay, so let's do that in our calculator. So we're going to substitute 4 in a of t. A of t is represented by 7.6 tan inverse 0.2 t, which is 4, okay, minus the integral from 4 to t, so 4 to 4, of 0.1 ln alpha x dx. Okay, this should give us 5.128. So the answer here is 5.128. Okay, and or you can say 5.128031. This is not our final answer yet. Okay, so we don't need to round yet to 3 decimal places. And we're going to do the exact same thing. Instead of 4, we're going to substitute the other values, 11.4417. And we're going to do the same thing here. Instead of t, we're going to put 11.4417. We get our answer to be 7.316,978. Okay, and if we substitute 36 in this function, so instead of 11.4417, we're going to substitute 36. And here also we're going to substitute 36. We get 1.7430 5.5 or 5.6. Okay, they want us to check when, so at what time t does A attain its maximum value. So clearly the maximum value of A is 7.316978 at time t equals 11.4417. So what do we say? So they said justify your answer, and we did using this table over here. So we can close this calculator. We say, therefore, at time t equals 11.442 weeks, okay, to 3 decimal places, A attains its maximum value of around or approximately 7.317, and that's our answer. Okay, so you can say 7.317 acres. Okay, and that's our final answer for part D. So we look at the scoring guidelines. Okay, so we got the exact same values, and we got our answer to be 11.442. So the number of acres affected by the species is a maximum at time t equals 11.442. So we drew the table and we solved, and we got all the marks in the scoring guidelines. Okay, so that's our answer for part D, and that was question 1.